Hey everybody, it's Miss Williams, and this is a video and presentation on Newton's Law of Cooling. We're going to need this information to do our Make Newton's Coffee project that we'll be doing a couple class periods. So it's important that you take notes and keep these notes with you. What is Newton's Law of Cooling? Well, Newton's Law of Cooling says that we describe the cooling of a warmer object to the cooler temperature of the environment. It says that if we leave something hot, like a cup of coffee, in a room over a period of time, the object will cool to the temperature of the room. This decrease is exponential because it decreases by a percentage each minute. Okay, here's a graph for you to look at. As you can see, the temperature is high, and as time goes on, it cools to whatever the temperature of the room is. The equation Newton used to model this temperature change is F equals R plus I minus R times e to the kt. Well, that's great and all, but what do all these letters mean? So F is the final temperature of your liquid or object that you want it to be. R is the room temperature or the environment's temperature around the object. I stands for the initial temperature of the object. K is a cooling constant, which it's obvious that things will cool at different temperatures. A pie is going to cool differently than a souffle, that will cool differently than tea that you make. T stands for time, and E, something we haven't talked about, but E represents a constant that represents a constant change. The temperature is ever changing. It doesn't change and then 5 minutes later it gets cooler. It's continually changing. So that's what E is. So here's a couple of example problems. Write these down also. So if we put a 170 degree cup of coffee in a room that's 68 degrees, then the temperature drops to 120 degrees in 20 minutes. Can you find what K is? So here's our equation. We know some things. We know 120 is the final temperature we want it to be. R, which goes in two places, is 68. It's the room's temperature. The initial temperature of the coffee was 170 degrees. E is you're never going to put a number in for E. E is a constant, and I'll show you how to do that a little bit later. K is what we're looking for, find K, and T was 20 minutes. Now the first thing you're going to have to do, you can do the stuff in the parentheses, 170 minus 68, but you're also going to subtract off 68 from both sides. So 120 minus 68 gives me 52, and then 170 minus 68 inside the parentheses gave me the 102. Everything else dropped down like it is. The next thing I have to do is divide both sides by 102. So 52 divided by 102 is 0.51. Now, just like we've done before, the variable that we want is in the exponent, so I'm going to have to change it to logs to find out what it is. So the base is going to stay the base, and the other two things switch sides. So E was my base, and it continues to be my base, and the 0.51 and the 20K switch sides to the equal sign. Now, we haven't talked about this, and we'll go into this some more, but log with a base of E is a special kind of log. It's called a natural log, and it is denoted as ln, and there's a button on your calculator for ln. So the natural log of 0.51 is equal to 20K. I'm going to put the natural log of 0.51 in my calculator, and I get negative 0.6733. Finally, I need to get the K by itself by dividing both sides by 20, and I end up with K. Sorry about that. That was Mr. Wall. I'm at school recording this. So divide both sides by 20, and you end up with the cooling constant for this cup of coffee in this situation was negative 0.0337. All right. One more example problem we're going to work. What if I decided on the previous problem that the 120 degrees was still too hot for me to drink? Alright, so now I want to know how long would I need to wait, because earlier I had to wait 20 minutes. How long would I need to wait for the temperature to reach down to 100 degrees, because I think that would be a safe temperature to drink it. There's my equation again, same equation. Alright, I'm going to plug in what I know. This time I want my final temperature to be 100 instead of 120. The room temperature remains at 68. The initial temperature remained at 170. This time I do not know T, but I do know K. I'm going to use the K that I just found on the previous screen. Alright, now I'm going to solve this process the same way. So the first thing I'm going to do is subtract 68 from both sides, and I'm going to combine what is in those parentheses. So 100 minus 68 gives me 32, and then 170 minus 68 is 102. Next, I need to get rid of that 102, so I'm going to divide both sides by 102. It's going to make the 102 on the right side cancel out, and it's going to leave me with 0.314 is equal to e to the negative 0.0337 t power. So now I have the base and the exponent by itself, so I'm going to change it to logs. And remember, log with the base of e is the same as a natural log. So the base stayed the base, the other two things switch sides. I'm going to do in my calculator the natural log of 0.314 and end up being negative 1.158. And finally I'm going to divide both sides by the negative 0.0337. I end up with 34.4 minutes. This answer makes complete sense because I had to wait 20 minutes for it to drop down to 120 degrees, so I would have to wait even longer for it to drop down to 100 degrees. Alright, make sure you bring your notes when you come to class next time. Have a good rest of the night.